Welcome, travelers, to Adventures in Security. In the next few minutes, we'll explore how DOS and DDoS attacks actually take systems down and the practical defenses teams use to stay online. The script for this video is available below. Today we're talking about denial of service attacks, DOS or DOS, and distributed denial of service, DDoS or DDoS. The goal is simple. Make a website, app, or network service so slow that real users can't use it, or knock it offline completely. In a DOS attack, the traffic or abuse typically comes from one main source. In a DDoS attack, it comes from many sources at once, often thousands of compromised devices, making it much harder to block. In this video, we'll break down how these attacks work, what they look like in the real world, and how defenders reduce risk before an attack and respond effectively during one. By the end, you'll have a practical checklist for protection and incident response. Denial of service attacks target availability, the A in the classic CIA triad of confidentiality, integrity, and availability. The attacker isn't necessarily trying to steal data. Instead, they try to overwhelm something that is limited. Bandwidth, CPU, memory, connection tables, database threads, or even an application's login workflow. If enough resources get consumed, legitimate requests can't be processed, and users experience slow page loads, failed logins, or complete outages. Think of it like a restaurant with only 10 tables. If an attacker can fill the tables with fake reservations or keep them occupied forever, real customers never get seated. That's the mindset. Saturate capacity or trigger expensive work until the service becomes unusable. Here's the key distinction. DOS often comes from one machine or a small number of machines. That's still harmful, but it's usually easier to identify and block using rate limits, firewall rules, or upstream filtering. DDoS is the scaled-up version. Traffic arrives from many different IPs and networks, often through a botnet, such as compromised computers, servers, or Internet of Things devices, under attacker control. Because the traffic is distributed, simple IP blocking fails. And because the volume can be huge, the target may not even have enough bandwidth to receive legitimate traffic. DDoS also complicates investigation. The visible sources are often victims too, so defenses tend to focus on absorbing, filtering, and shifting traffic rather than finding the attacker. Most attacks fit into three buckets. First, volumetric attacks. The attacker sends massive traffic to saturate bandwidth, like trying to fill a highway so nobody can drive. Second, protocol or state exhaustion attacks. These exploit how network protocols work to overwhelm devices like load balancers, firewalls, or servers by filling connection tables or forcing expensive protocol handling. Third, application layer attacks. Instead of raw volume, the attacker sends requests that look normal, but are designed to be costly, like repeatedly triggering search queries, login attempts, shopping cart actions, or API calls that hit databases. Application layer attacks can be tricky because the request rate might be moderate, yet the back-end cost is high. Great defenders learn to recognize which category they're facing because response strategies differ. DDoS often starts with a botnet. The attacker controls many devices that can send traffic simultaneously. But there's also a common force multiplier called reflection and amplification. The attacker sends a small request to an open service on the internet, but spoofs the victim's IP address as the source. That open service then sends a much larger response to the victim, so the victim gets flooded, and the attacker's traffic cost stays low. The reflection part is that third-party servers reflect traffic toward the victim. Amplification is that responses are larger than requests. You don't need to memorize protocol names to get the concept. Attackers look for internet services that will reply loudly to a whisper. Modern defenses assume attackers may use both botnets and amplification. So what does a DOS or DDoS look like from the defender's seat? Often you'll see sudden spikes in inbound traffic, a jump in new connections, or unusual request patterns, like repeated hits to one endpoint. On the user side, symptoms are slow pages, timeouts, and server errors, especially 5xx errors. The most useful approach is to monitor in layers, network utilization and packet rates, load balancer metrics like connections per second, and application metrics like request latency, queue depth, database CPU, and thread pools. Also track business indicators, checkout failures, login failures, API error rates, because they tell you whether real users are suffering. In response, you want to answer, what's saturated, where and how fast is it getting worse? The best DDoS defense starts before an incident. Resilience engineering. If one component is a single choke point, such as one firewall, one region, or one database, you're easier to knock over. Scale horizontally where you can, add redundancy, and avoid designs that require every request to touch a fragile backend. CDNs and Anycast networks help because they distribute traffic across many locations and absorb floods close to the edge. Caching is also a huge win. If your app can serve popular content without hitting the database every time, an attacker has fewer expensive levers to pull. Finally, isolate critical services. If your main website gets attacked, your admin panel, payment processing, and internal APIs shouldn't collapse with it. Resilience reduces the blast radius and buys you time during response. Next is filtering, deciding what gets in. For large DDoS, you typically need upstream help. A cloud DDoS protection service or ISP scrubbing that can filter traffic before it saturates your link. At the application layer, a WAF, Web Application Firewall, can block suspicious patterns and common abuse, and bot management can distinguish real browsers from automated traffic. Then add rate controls, global and per-user rate limits, API keys with quotas, and protection for expensive endpoints like search, login, and password reset. Also use circuit breakers and timeouts so one overloaded dependency doesn't cascade failure across the system. The theme is, don't let any single user or attacker consume unlimited resources, and don't wait until the request reaches your most expensive backend component. During an active attack, prioritize speed and clarity. First, confirm what you're dealing with, such as a volumetric flood, protocol exhaustion, or application layer abuse. Identify what's saturated, like bandwidth, connection tables, CPU, database threads, because that tells you which lever to pull. Second, contain. Turn on DDoS protection under attack modes. Route traffic through scrubbing. Tighten WAF rules. Increase rate limits. Add challenge steps like CAPTCHAs, where appropriate and temporarily disable non-essential features that are expensive. Third, communicate. Create a clear incident channel. Assign roles and provide user-facing status updates so customers aren't left guessing. Finally, preserve evidence. Keep logs, NetFlow data, WAF events, and timestamps. You'll need them for the post-incident review and to harden defenses. Once the service is stable, don't just move on. This is where you get stronger. Run a post-incident review. What signals detected the attack, which mitigations helped, and where did you lose time? Update alert thresholds to catch early signs without causing noise. Improve your playbook. Who contacts your ISP or DDoS vendor? How traffic gets rerouted? Which WAF policies to enable? And which endpoints to protect first? Then practice. Tabletop exercises help teams learn the flow without pressure. Load testing shows where your real bottlenecks are. Game days validate that your toggles and automation actually work when you need them. DDoS defense is not a single product you buy. It's a capability you build, measure, and refine over time. That's it for this video. If you learned anything, please remember to give us a thumbs up and subscribe. And until next time, be careful what you click.